Hey everyone, welcome back to the channel. In this video, we are going to solve another problem on a slow and fast approach. If you haven't seen my previous video on a slow and fast approach, do watch my previous video where I have taught you what the fast and slow method or approach or technique, when to use, how to use. But before solving this problem, I would recommend you to try solving this problem by yourself. If you haven't able to solve this question by yourself, then you are free to watch any tutorial, any solution. So without wasting any more time, let's dive into the problem. So this problem is saying that you have given the head and you have to detect whether a linked list is contain or containing a cycle or not, or you can say a loop. But what is a cycle or a loop? So you can see there's a clearly a kind of loop things occurring here. From 2 you move to 0, then from 0 you can move to -4, then from -4 you again move to the 2. So there's a kind of cycle, a loop thing. So that what you have to detect. If linked list contain a cycle, you have to return true. And in example 2, there's a cycle 2. So you return true. In example 3, there was not any cycle, there was a single element which is pointing to a null, which is not pointing to null, its next is pointing to a null. So basically there's not any cycle, so you return the false. So how did we solve it by slow and fast? Let's try to understand it clearly. Let me open my brush. Okay, so I have prepared something for you. I have prepared a demo link list. Suppose this is our link list. And initially, our slow and fast will be pointing to the head of the linked list. That is the root, or you can say the first element of our linked list. From here, not from here, from here. Yes, slow is fast pointing to the head. Then my slow moves to the first element because I have told you slow will move one step and fast will move two steps. If you haven't watched my previous video, do watch it. From here, my slow moves again. My slow wait. Why I need to open my brush every time? Okay, so my slow moves to for one step and my fast moves to two steps. Then again my slow moves from here to here and my fast moves to here to here. Okay, two steps. Then again slow moves one step, fast moves two steps. Okay, everything is fine till here. So then again, my fast moves here, my slow moves here. Then again my slow from here it moves to here and my fast moves here. The moment they are pointing the same node again, except the head node, means there is a cycle. Got it? The moment my slow and fast are both are pointing the same element. They are pointing the same element except the head. That means there is a cycle. And how can you say there's a cycle for granted? That's why uh, if there wasn't any cycle, then my fast would probably reach to its end, or you can say null. But that's not the case because there is a cycle. That's why they are meeting. That's why my fast would come back to this node because my fast is moving two times faster than my slow. And why they are bound to be meet at the if what suppose even if they were cycle, how it is guaranteed that they would meet on the same junction or same node? Because if they are keep going on the same route, means if they are keep going on the same route and my fast is moving faster than my slow, so it's like my fast is chasing the slow, you can say. and my fast is moving the faster. Suppose you are going in a distance, you are traveling in a distance, or you are going a road, and someone is chasing from behind you, and this is faster. It's obvious that it's gonna meet you or chase you at some point. That's what fast is doing basically. So my slow will keep moving into this cycle, and my fast there will be some time when my fast will chase to my slow and you can say my fast will meet to the slow. They are bound to be meet at some point if there's a cycle. If there's not any cycle, then they will probably not meet at any point. I have prepared this for you too. Suppose there's not any cycle. What will happen? The fast moves here, then fast moves here, and at the end, my fast moves to the null. So the moment my fast reaches the null, there's not any cycle present on a linked list. If there was a cycle, then probably my fast moves to the cycle again into the loop and keep traveling in a loop until they meet to the slow. So that was the basic intuition behind to detect a cycle in a linked list. But how will we code it? Let's move to the code editor, lead code editor, and try to solve it. Let's copy this thing. We will make a list node of type of a pointer type of slow this with this pointing to the head. The same thing for the head fast, which will again gonna point to the head. What the we need a while loop. So let's write while there will be some condition. We will write it later. Inside the while loop, what we need? We need a slow. We have to move the slow. So let's move the slow. Slow will move to the one position by one position. So slow will move to the slow next of slow, and my fast will move two steps. So my fast will move to the next of next. Okay. So what we need, like I said, the moment if if my slow will be equal to fast means they are pointing on the same node means I got a loop, I got a cycle in a linked list. So I will simply return it. What I will return? I will return true. I will simply return true means I got a cycle because they are pointing on the same element. And if they got out of the loop means I didn't got a cycle in linked list, so I will return a false. So what I will write the condition here. The condition will be same. The moment my fast reaches the end or reaches the null, I will terminate my loop while loop. So my fast should not be equal to null, capital null, and my fast next of fast should not be equal to null. Okay, if I will run this code, it will work exactly fine. It should be running. Okay, and it's running. Let's submit it up. Then let's move to the Java solution. The Java solution I have already written, but there's some few tweaks that in Java don't have asterisks, so remove the asterisks, and the null should be in small and use the dot instead of arrow. Everything will remain same for the Python. In Python, the while fast and fast dot next, everything will be same, but True with a capital T, false with a capital F. Okay, so with this will be probably a short video. I hope you understand the intuition behind the how to find or whether to detect the loop or cycle in a linked list, in a simply linked list. So with this, if you like my video, do like and subscribe. If you have some query or comment, do comment below or in the comment section. I will provide the problem link in the description so you can directly jump to the solve a problem. But before solving any problem, try to solve it by yourself. With this, I'm wrapping up. Thank you all.